Okay, so we're going to talk about complex numbers today, which includes our imaginary numbers. And in Chapter 1, you learned about different subsets of real numbers. The set of real numbers is itself a subset of a larger set of numbers. And before, all you knew was real numbers. And now I'm telling you, nope, the real numbers is actually a subset of a much larger set, the complex numbers. And what this has to do with is simplifying square roots of negative numbers. All right? So we're going to go over here, and let me grab a highlighter today. And we're going to talk about the imaginary number I. And here is what it is. I equals the square root of negative 1. That's what I is. Okay, let me show you a little something about I. I squared here is the square root of negative 1 times itself. Equals negative 1. Because you know that squaring and square root undo each other. So I squared has a real number value, and that real number value is negative 1, and that is going to come up in our simplifications today. So let me show you an example of how you can take a square root of a negative number using the imaginary number I. And we're going to use our product rule for square roots that we had before. And if you're taking the square root of any negative number, it's really negative 1 times the positive value of that number, correct? Which, using your product rule, splits it up into the square root of negative 1 times the square root of that number. And the square root of negative 1 is I. So I, square roots of A. So what I want to do over here is show you that example using the square root of negative 5. So we would split this up into the square root of negative 1 times the square root of positive 5. We want to pull that negative 1 out of there because the square root of negative 1 has a value, and that value is I. So this becomes I square roots of 5, which is super cool. Interesting thing, when you're looking at something like this, the square root of negative 5 quantity squared, when you're doing that, you don't want to say square root of negative 5 times square root of negative 5, multiply the negative 5s and get square root of 25. Your product rule does not work for negative square roots, only positive square roots. What you have to do is rewrite the square root of negative 5 as I square roots of 5, like is done here. And then when you square that, you square the i's, you square root, or square the square root of 5, which gives you negative 1, because I squared, remember we said equals negative 1, times 5, which is negative 5, and not positive 5. So that's what we're doing today. So what we're going to do is some examples here at the bottom of the page. We're going to simplify some square roots. Now, first of all, if I'm looking at positive 18, how would I split this up? 9 and 2. Okay. We're going to split it 3 ways. The square root of negative 1, the square root of 9, and the square root of 2. Okay, because we want that negative 1 to be all by itself. That square root of negative 1, that's an I. Square root of 9 is a 3. And so the way that this simplifies is 3I square roots of 2. That is simplified. Okay. There is nothing else you can do with it. That is the answer. Okay. You are now going to begin your life of having answers that include the letter I. They should never include I squared because I squared simplifies to -1 and you can replace it with that. Square root of -12. So let me ask you, if it were positive 12, how would we split it?
4 and
3. So what we're going to do is split it 3 ways.
-1,
-1,
4,
4,
and 3.
and 3. Now, the square root of -1, that gives us I, and the square root of 4, that gives us 2. So this is going to give us 2I square roots of 3. Okay? Square root of -25. Now, we can take the square root of positive 25, so we're going to just split it into a -1 and a positive 25. Now, this is an I, and this is 5. So out of this, your answer is just 5I. And out of this, we really can't split up 7 any possible way, but we are going to pull out the square root of -1. And the square root of -1 is your I. So my answer here is I square roots of 7. Okay, the next thing we're going to do with this is I'm going to show you how to graph this. It is kind of silly in some regards that we're graphing this, but I'm going to tell you the state of Michigan wants you to know how to do this. They didn't say we have to focus on it as the highlight of our year, but we do need to spend 5 minutes in class covering how you would graph such a thing. Okay? This is not graphed on a real number graph. Your XY graph, because there are no imaginary numbers on your real coordinate graph. It's on its own graph. Its own graph is the complex number plane right here. Now, complex numbers are written in a particular form, and that particular form is the form A plus BI. A is a real number, and the B is a number. It can be, it's going to be a real number, but once it has the I attached to it, it now becomes an imaginary number. So this is the imaginary part, this is the real part. Let me give you an example. An example of a complex number would be 3 plus 2I. 3 plus 2I is a complex number. Don't try to conceptualize what amount this is, because there is not a conception of this amount. It is an imaginary number. So it's kind of like you just have to go with the rules and go with the flow. We're going to learn how to do calculations with complex numbers, and you'll find out that really they're out there to hold a place for when things go basically wrong. This holds the place, allows you to keep calculating until it brings you back around to real numbers again. So it's fantastic. All right, here is an axis where this particular number, this is the one they're doing. Let's highlight it here. 3 minus 2I. Okay? So what you know as the x-axis is the real number axis, and what you know as the y-axis is the imaginary axis. So your real number part is 3, so you're going to go 3 units to the right, and your imaginary part is negative 2I, so you are going to go 2 units down. All right? So let's do a couple of these graphs. So I have my fun little guy right here. I sure will. And we're going to draw. And bear with me because I'm going to lift this up and squeeze this
Draw
on.
a graph too.
Pardon?
Should we draw like the graph?
You should draw a graph when you're doing this. But you wouldn't put X and Y on it. This is right here, the real. And this right here is imaginary. And if it helps, write that on there so you get used to remembering which is which. So negative 5 plus 3I, this is my real number, negative 5. we're going to go negative 5 to the left right here, all right? And I'm not putting it out there yet, all right? We're just sitting there. Now, plus 3i means go up 3, and that's going to give me right here. There is where it is graphed. This is negative 5 plus 3i. All right? Now, I will tell you, in your homework, when it tells you to graph, it'll also tell you to find the absolute value that has to do with this. We're not doing it, so please just ignore it. Now, this one is 6i. So what do you think the real number part of this is? Since you don't see it. It is 0. So 0 on the real number axis, and 6i is up 6. So right there. And this little guy right there is 6i. See, it's just, it looks just like an XY axis, but there it is out there on the imaginary plane, the complex number plane. That's all there is to that. I want to show you how to add, subtract, multiply, and divide. Okay. Now, adding and subtracting is super easy. All you're doing is combining like terms. Okay? So this is a complex number and this is a complex number. I am adding those together. So I have 4 plus negative 4. What does that give you?
0.
I have negative 3i plus 3i. What does that give you?
0.
Okay, so really that's like 0i, and this is all 0. Okay? Let's do one with subtraction. Now remember, when you're doing subtraction, this is what we should do, is bring down our 5 minus 3i. But since we're subtracting, you can distribute this negative, and negative times negative gives you plus 2. Negative times positive gives you minus 4i. Now you can add. All right? So I have 5 and 2 are my real number parts. Give me 7. Negative 3i and negative 4i combined gives me negative 7i, so 7 minus 7i. All right? It's just combining like terms. That's all you're doing. Now, you treat I just like you would treat it if it were a variable. It's going to work the same way. Next thing we're going to do is we're going to multiply some complex numbers. And in this situation, this looks like a distribution situation, right? That's exactly what it is. So we're going to distribute. All right. 3i times negative 15 is negative 15i. Now I have 3i times 2i. Would you agree that gives me 6i squared? So far, so good? One more step.
Divide by 3.
No. Your next step here is you can't leave I squared. I squared equals negative 1.
Oh, God.
So we're going to take this and replace it with a negative 1. Okay, so 6 times negative 1. So we do agree this is negative 15i minus 6, right? Because 6 times negative 1 gives you negative 6. Now, remember, complex numbers are written real part first, imaginary part second. So we're going to write this as negative 6 minus 15i. All right? What do you think the tool is that we would employ in this particular situation? There's a lovely little word. This is FOIL. Okay, my firsts, 4 times negative 1 is a negative 4. My outers, 4 times negative 2i is minus 8i. My inners, which is 3i times negative 1, is minus 3i. And my lasts, 3i times negative 2i, is minus 6i squared. What you need to keep in mind is every time you end up with an I squared, this is really a negative 1. So, I have negative 4. Combine these like terms. And negative 6 times negative 1 gives you plus 6. Now notice, you can now combine like terms again. You have a negative 4 and a positive 6 gives you positive 2 minus 11i. All right? So the only really new thing, you're treating I much like you would treat it if it were a variable, except that once you get to I squared, that changes into a negative 1. So let's go ahead. This one gets kind of interesting. Would you happen to notice here is both binomials contain the exact same terms, except that one has a plus in the middle and one has a minus in the middle, right? I will tell you that when you have that, those are called conjugates. And every time you multiply them, you will get a real number. No imaginary number will come out of this. All right? You're going to get a real number. So let me show you how that happens. So we're going to FOIL. Negative 6 times negative 6 is positive 36. My outers, negative 6 times negative I is plus 6i. My inners, positive I times negative 6 is minus 6i. And my lasts, positive I times negative I is minus I squared. Now, would you agree the positive 6i and the minus 6i cancel out to 0, right? Okay. And would you also agree that this guy right here becomes a negative 1, right? Yes. Okay, so this becomes 36 plus 1, which is 37. All right? Now, let's go ahead to the bottom of this page, because we're going to do some division of complex numbers. And the issue with dividing complex numbers is that, remember, an I represents a square root. If an I represents a square root, and we know we can't have square roots in the denominator, then we can't have I in the denominator, can we? So we have to rationalize. So here's what we're going to do. I have a 3i in the denominator. There's no problem having a 3 in the denominator, but I cannot have an I down there. So here's what I'm going to do. Multiply by I over I. Just like when I was trying to get rid of a square root in the denominator and I was multiplying by that square root over itself, I'm going to use I over I, because really that's just 1. Now, in the numerator, I might want to distribute. All right? So this would give me 9i plus 12i squared. Fair enough? And in the bottom, I have 3i squared, right? Okay. This I squared becomes a negative 1. And this I squared becomes a negative 1. So here's what I have. 9i minus 12 over negative 3. Next thing, I can actually split this up into two fractions and simplify further. So this is 9i divided by negative 3 minus 12 divided by negative 3, which gives me 3i plus 4. And remember, we write the real part first, the imaginary part second. So let's switch it around. This is 4 plus 3i.
Why is the first 3i not negative?
Oops, it is. This should be negative, which means this isn't positive. This is negative right here. All right. The second one is more difficult, and the reason why is because I have a binomial here. You have to remember the trick to doing this. Do you remember up above in example B? If you have conjugates and you multiply them, your answer becomes real, right? Well, we need to get a real number on the bottom. We can't have an imaginary number on the bottom. So the trick we're going to do is we're going to use the conjugate of the bottom. So we're going to multiply by 1 plus 4i.
Why is it plus?
Because that's the conjugate. And the conjugate, when we multiply conjugates, we're going to get real numbers. So watch what happens when we FOIL this. So if it helps, put these all in parentheses so you go about FOILing them. You have to FOIL the numerator, FOIL the denominator. So in the numerator, first, 2 times 1 is 2. My outers, 2 times 4i is plus 8i. My inners, 3i times 1 is plus 3i. And my last, 3i times 4i is plus 12i squared. Okay, go to the bottom. FOIL, 1 times 1 is 1. My outers, 1 times 4i is plus 4i. My inners, negative 4i times 1 is minus 4i. And my last, negative 4i times positive 4i is negative 16i squared. Now, you would agree that down here, these are going to cancel each other, right? And this I squared becomes a negative 1, and this I squared becomes a negative 1. Okay? So here's what we're going to have in our next step. Would you agree 8i and 3i is 11i, right? So 2 plus 11i minus 12 over 1, and then negative 16 times negative 1 is plus 16, right? Okay, combine your like terms, whoops, in the numerator. There we go. 2 plus negative 12 gives us negative 10 plus 11i. On the bottom is 17. You can leave that all as one fraction, or you can split it up into 2 fractions if you want, which would be negative 10 over 17 plus 11i over 17. It doesn't matter which of those 2 ways that you leave it. Okay. Here's another thing. Check this one out. Factoring using complex numbers. Do you remember how when we had x squared minus 81 and we were going to factor that this factored into x plus 9, x minus 9, right? And there was no formula for something like this. Well, imaginary numbers are going to allow us to do this with a plus right here. All right? So do you see how x squared minus 81 is x plus 9, x minus 9, right? Check this out. This becomes x plus 9i, x minus 9i. All that is if you have a plus there, you have i's right here. Beautiful. So let's go ahead and do this one. First thing, you've got a greatest common factor. Factor that out. Take your 2 out. It leaves you with x squared plus 16. What's the square root of 16? 4. All right, so 2. This is x plus 4i, x minus 4i. And if you were to FOIL this, you would get yourself right back to 2x squared plus 32. All right? So the very last thing that we've got to do today is, now that we know a little bit about imaginary numbers, we are going to use those imaginary numbers to solve quadratic equations that have imaginary solutions. Because yesterday we learned they could have imaginary solutions, but today we're going to find out what they are. So in this example, and I'll use something I know you'll like, that's the quadratic formula. Would you agree A is 2, B is -3, and C is 5? So far, so good? Okay, so X equals -b would be +3 plus or minus the square root of b squared would be 9 minus 4 times a, which is 2, times c, which is 5, all over 2 times a, which is 2. All right, let's go to that square root part there. And would you agree that this is 9 minus 40, it looks like, right? So far, so good. And what does it give us? -31? All right. So 3 plus or minus the square root of 31 all over 4. Whoops, -31. And here's what we're going to do with that. Simplify it, take out square root of -1 from the 31, and your answer is 3 plus or minus I square roots of 31 over 4. If you want to make that two separate fractions, you're welcome to do that, but that is simplified. All right, should we do one more of these?
How would you simplify that more?
You can't.
Oh, you just split it up?
You could just split it up into 3/4 plus or minus I square roots of 31 over 4. But you don't have to. It's the same thing either way. Want to do one more? Let's do one more. All right. So over here, A is 3, B is -1, C is 2. Using the quadratic formula, -b would be +1 plus or minus the square root of b squared would be 1 minus 4 times a, which is 3, times c, which is 2, all over 2 times a, which is 3. Now, in the square root, you would agree in here we've got 1 minus 24, right? Yep. Okay, which is -23. So this equals 1 plus or minus the square root of -23 over 6. Last thing we need to do, simplify this. Separate square root of -1 from the square root of 23. And this gives us 1 plus or minus I square roots of 23 over 6.